Hello everyone, welcome to Calculus 3. This time we are moving to Chapter 3. The first two sections of Chapter 3, vector-valued functions. Vector-valued functions. What is a vector-valued function? Well, when we have a function with one single variable, it's taking two values, and those two values form a vector. That is a vector-valued function. For example, this is this is a very general form of vector-valued function in the two-dimensional space. And in the three-dimensional space, certainly we are having three components, okay. And also, you may want to know, either in the two-dimensional or three-dimensional case, a vector value function really represents a curve, And for quicker explanation, I do have an example here from the textbook. It says, create a graph for the vector value function like such. It might be harder to see what the graph would look like. But anyway, if you understand the idea of vector valued function, which really means that this first component, it is for the x value. Second component, it is for the y value. So I wrote out those two equations, y equals and x equals. Y equals 2t minus 3, which really means t equals 1/2 times parentheses y plus 3. And I use this result, plug into the equation for x. X equals t squared minus 1. X equals 1/4 times parentheses y plus 3 squared, and then minus 1. And it might be harder to figure out what the graph of this equation would look like, but I say this is a quadratic function, right? Usually we have quadratic function, we have y equals x squared, so that's a parabola opening upward. And now this time what we are having here is the x equals y plus 3 squared. So I said that this is a parabola opening to the right. And also compare with the vertex formula. I say the vertex, it is at a point y equals negative 3 and x equals negative 1. I think this should be negative 1 here. And also, if you are wondering how the graph would look like, this is a vertex at a negative 1, negative 3. And also it has two y-intercepts because the parabola opening to the right, so possibly it could have y-intercepts. Those y-intercepts are at a negative 1 and a negative 3. So roughly, it's having the shape like this. And this is the beginning part of a vector-valued function. A vector-valued function is a function with one single variable such that the function value is a vector. And also in general, in the two-dimensional case or three-dimensional case, a vector-valued function really would represent a curve. Like in this case, we are having a curve here. And also in the three-dimensional case, we are still having some curves. Okay. Thank you for watching.